Hello guys, welcome to my channel. So today we are going to continue the topic of collision. We started with collision and we stopped at that part. We said that during collision there are three types of collision, and during collision the velocities of the bodies should change, and there are three types of collision: elastic collision, inelastic collision, and perfectly inelastic collision. In elastic collision, the shape and size of the bodies do not change. In elastic collision, what the momentum and kinetic energy remains conserved. In inelastic collision, the momentum remains conserved but kinetic energy is changing due to small deformation, and this kinetic energy is stored as a deforming force, as a potential deforming potential energy it is stored. It means some part of it is lost, like when we drop this pen, see the sound is heard, some part of the energy is lost in the form of sound. That is what is meant here. Okay, so now we are going to derive the formula for final velocities. Means when two bodies collide, they collide with an initial velocity, and after that they move with different velocities. Right, that's the definition of collision. That is, they should move with the different velocities. And now we are going to derive that formula. Okay, final velocities. So let's consider two bodies. This body has mass m1, this has mass m2. They are moving with velocity u1 and u2. They are in a horizontal plane. They collide, and due to collision they suffer some deformation. Due to collision, and now they have formed a system, and the system is moving with a velocity v. After that they move as separate bodies. This m1, m2 with velocities v1 and v2. They have changed their velocities. Their velocities have changed. Right. Now, now we are supposing we are taking u1 as greater than u2. We are taking u1 greater than u2. Now, can you say which one, v1 or v2, will be larger? Here, when these two bodies collide, we have studied that during collision we take only impulsive forces in consideration. So here, which is the impulsive force acting? Of course, it's a normal reaction due to the contact between these two bodies. M1 gets a normal reaction in this direction, M2 gets a normal reaction in this direction. See, which one, v1 or v2, will be larger? See, check here. This is a body m1, and this body m1 is having a final velocity v1. Earlier it had an initial velocity u1, and at this point of time, onto the body m1, a normal force is acting in this direction, and this direction is opposite to its later final velocity. See, its velocity after collision is opposite to the direction of the force it is attaining. That is, this velocity is less. It means this force is reducing that velocity. See, this force that this m1 is getting, this is reducing the velocity it is getting. This velocity is being distributed to these two masses, and as this velocity is the opposite to the direction of this force, this velocity is reducing, means this force is reducing that velocity. So obviously we can say that v1 is less than v2, that is v2 is the greater, because for v2 the direction of force and the velocity direction, these are on the same direction, therefore it will be larger. Now, we can mark up to here this part as the deforming part. Right. See, here up to here it is being deformed. Right. So this is the deformation part, and this is the reformation part. After deformation they are being reformed. This is the reformation part. See, this is pure collision. So during collision, momentum remains constant. Therefore, according to conservation of momentum, CIF is CM. According to conservation of momentum, what we can write? According to conservation of momentum, we can write m1u1 plus m2u2 is equal to m1 plus m2 into v. See, during this part. Actually, we do not consider this part because this is just for a small interval of time. See, collision takes place only for a small interval of time. So, it is okay if we don't consider this. We can just consider this part, velocity before collision and after collision parts. So, after collision it is m1 v1 plus m2 v2. Suppose this is elastic collision. During elastic collision, what else is conserved? Kinetic energy is conserved. Right. During elastic collision, kinetic energy is conserved. So here we can apply the conservation of kinetic energy. Apply the conservation of kinetic energy and say half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. See here. Right. This is during elastic collision. But if it is, now we can find the final velocities how after we can solve these two equations. M1 and U1 we know, M1 U1, M2 U2 you know, M1 and M1 and M2 also we know. There are two unknowns. We can solve two unknowns by two equations. We can solve these two equations and prepare a velocity for U1 and V1 and V2, and that we will come across later. But first we should consider the case of inelastic collision. If it is an inelastic collision, what do we do? If it is an inelastic collision, during inelastic collision, we cannot write like this. We cannot say that kinetic energy is not conserved. So, half m2u2 square is not equal to half m1 v1 square plus half m2 v2 square. This statement is wrong. So, we only have this conservation of momentum equation. But we cannot solve the equations for V1 and V2 using this equation only. For this purpose, a new term is introduced by Newton that is known as coefficient of restitution. So, now we will see a new part. We will come to this later. But now there is a new term that is known as coefficient of restitution. Coefficient of restitution. Okay, wait a minute. Okay, coefficient of restitution. It's denoted by the letter E. Let me state the equation for coefficient of restitution. In simple terms, it is impulse of deformation. Impulse of deformation. Deformation divided by impulse of reformation. Impulse of reformation divided by impulse of deformation. You remember the part when we said when two bodies are acting like this, they are colliding, and after that they are separating as two bodies. We need this picture here for this derivation. This has a velocity u1, u2, mass m1, m2, combined velocity v, m2, m1, m2. This has a velocity v1, velocity v2. This part is what? This part has velocity this part is the deformation part and this part is the reformation part. Here here we said that u1 is greater than u2, and here we say v2 is greater than v1, right, because of the normal force. Now, what is impulse of reformation? First, we will denote impulse of reformation as JR. JR is change in momentum during reformation. See, impulse is change in momentum. So, JR is change in momentum during reformation. So, what is change in momentum during reformation? Mass into final velocity minus initial velocity. So, during reformation, see the reformation part. Which was the final velocity? Final velocity, first let's consider m1. We can consider either m1 or m2. Here we will just consider m1 part. We can take any mass. Either we can take m1 or we can take m2. It's no problem. So what is the final velocity of m1? Here the final velocity of m1 is v1. m1 into v1 minus initial velocity of m1 was v. If we take m2, it is, what is the final velocity of m2 is v2. Initial velocity of m2 is v. Now we are taking JD. What is JD? JD is change in momentum during deformation. That is when M1, what is the final velocity of M1 during deformation? Final velocity V, initial velocity U1. In case of M2, final velocity was V. M2 also had final velocity V. Initial velocity was V1. Now we got JR and JD. What is E? E is impulse of reformation. JR divided by JD. Right, JR divided by JD. But see here, we have an unknown term V. We don't know what is the value of V. We know V1, we know V2, U1, U2, or we know. But this is just for a short time and we don't know its value. So we have to convert this value. For that, during inelastic collision, we have another term. What was that? We had conservation of momentum, M1V, M1U1 plus M2U2 gives M1V1 plus M2V2. Now from here, and we had also said that is equal to this during this small amount of time, it's M1 plus M2 into V. From this we can write V in terms of U1 or U2 or in terms of V1 or V2. We can write in terms of U1 and U2. V is equal to M1 U1 plus M2 U2 divided by M1 plus M2. Now we substitute this equation to JD and JR. JD is equal to, we can write in terms of M2. When we write in terms of M2, this is V1, right? Sorry, we will write in terms of M1 because this, in the equation of V, we have U1 and U2. U1 and U2 are present only in the equations of M1 at JD. M1 into, what is the value of V? We had got the value of V, that is M1 U1 plus M2 U2 by M1 plus M2 minus U1 cross multiply minus U1 M2, right, M1 plus M2, cancellation, M1 divided by M1 plus M2 into, we take M2 out, U2 minus U1, there we get a JD, that is impulse of deformation. Now impulse of reformation. Impulse of reformation we got JR is equal to, we write in terms of M1 into V1 minus V. That is what we got here, right? Now we substitute the value of V here also. M1 into V1 minus M1 U1 minus M2 U2 divided by M1 plus M2 cross multiplying. We cannot cancel, right? M1 into M1. See, here what is the speciality? Here we are having V1. So if we do like this, we cannot cancel out, right? So for that purpose, we can write V as, and from here, we can write V again as M1 V1 plus M2 V2 by M1 plus M2. Right. So it's just a simple trick. So here we are exchanging, removing this V1 and V2, U1 and U2 and putting it V1 and V2. See, both equations are correct. But for here, during this time, we are taking V1. Here V1 is present here. V1 we have to cancel out. So to cancel this V1 out, we have to put these V in terms of V1 and V2, right? So now we can cancel out. Cross multiplying, cancelling out, we get M2 M2 into V1 minus V2, right, M2 into M1 into V1 plus V1 into M2, right, so M2 is taken out, V1 by V1 minus V2 divided by M1 plus M2. Okay, now we just have to find impulse. We just have to find coefficient of restitution E. Now what is E? E is simply JR by JD. E is JR by JD. Impulse of reformation by impulse of deformation. What is impulse of reformation? This is impulse of reformation. M1 M2 into V1 minus V1 minus V2 divided by M1 plus M2 divided by M1 M2 into U2 minus U1 divided by M1 plus M2. Cancel, 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 cancel. Then we will get as V1 minus V2 divided by U2 minus U1. Right. Second. Okay. Earlier we had said that U1 is greater than U2. Also V2 is greater than V1. So this equation does not have a nice look, right? Because see here V2, we are removing a larger quantity from a smaller quantity. It does not look nice. So actually we can take a negative out. If you take a negative out, it becomes V2 minus V1 by U1 minus U2. Negative negatives are cancelled, the two negatives are cancelled. So this is the equation of coefficient of restitution E. That is, E is equal to relative velocity of separation divided by relative velocity of approach. Ta-da! So this is the value of E. Now with this value, we can calculate, we can solve the equation of V1 and final velocities and V1 and V2 for inelastic collision too. Right. So now we are going to see some peculiarities about this value E. So what is value E? E is the relative velocity of separation after collision. After collision, that is V1 and V2. V2 minus V1, that is relative velocity. You heard about relative velocity, right? These bodies are moving in the same direction, so we can subtract these two values to get the relative velocity of separation, because the bodies are separating after collision. Relative velocity of approach, because the bodies are approaching before collision. Before collision they are approaching and then they collide, then after that they are separating. Therefore relative velocity of separation divided by relative velocity of approach. Now can you say for elastic collision, what is the value of E for elastic collision? For elastic collision, E has the value equal to 1. Say E is equal to V2 minus V1 divided by U1 minus U2. In elastic collision, these bodies, they are not changing, they are moving in the same direction. See, E value is 1 u1 minus u2. It means their relative velocities. Their relative velocities are same. That means their relative velocity before separation is equal to their relative velocity after separation. So for elastic collision, E value is 1. For perfectly inelastic collision, perfectly inelastic collision, E value is 0. That means in a perfectly inelastic collision, one body gets embedded into another body. So what will be the final relative velocity? There is no relative velocity, that is 0, because these bodies have become joined together, they have become a combined system. So what will be the relative velocity of separation? There is no such thing. So that is 0. Therefore E value is 0 for perfectly inelastic body. For elastic collision, E value is 1. For perfectly inelastic collision, E value is 0. Then so obviously E value is less than 1 and it's greater than 0 for any inelastic collision. Now, actually this E value, it does not depend on shape or anything like that. Shape or does not depend on mass. It only depends on type of material used, because velocity depends on material, right? If a body is pushed, two bodies, let's say this pen and this board, they are pushed. Now see, they will get velocity depending upon the material. This body, it is made of lighter material. This is made of heavier material. It will depend on material, but it does not depend upon mass or shape. Okay, so this inelastic collision, E value, coefficient of resistance E value, restitution E value does not depend on shape or mass, but it depends on material. Okay, hope you understand the concept of coefficient of restitution. Now we can find the velocity value. Final velocity during elastic collision. It's actually a long derivation method. We can do if you want, but actually it's not need, because all we have to do is solve the momentum conservation equation is equal to m1 v1 plus m2 v2, and the kinetic energy equation half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. We can cancel out all the halves and we can rearrange this. Rearranging equation 1, m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. We get m1 into u1 minus v1, m2 into v2 minus vu2. Now from this we are again rearranging, is equal to m2 v2 square minus m2 u2 square. Now we are taking out, see, this is u1 square minus v1 square is equal to m2 into v2 square minus u2 square. Now we are dividing this equation. So let this be equation 1, this be equation 2. 1 by 2, we get, what do we get? We get u1 plus v1 is equal to v2 plus u2. Right, because this is the expansion of a square minus b square. v1 is equal to v2, or v2 is equal to u1 plus v1 minus u2. Substituting this equation directly to this equation, we get the value of v1. v1 we will get as, so you can do it by yourself, it's actually very simple. m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 u2 divided by m1 plus m2. See, it's actually pretty simple. Now if you know u1, you can actually need to only by heart one value, because during entrance examination we did not get the time to solve these long equations, so we actually pretty much by heart this velocity equation. v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. It has a pretty much pattern, so v2 is equal to, we can just rearrange everything, so m2 minus m1 divided by m1 plus m2 into u2, it's u2 this time, plus 2 m1 u1 divided by m1 plus m2. This is for what? Elastic collision. In inelastic collision, what you have to do is that you have to take the momentum conservation equation and the square equation of coefficient of restitution and then solve. Taking those two equations, momentum conservation equation, m1 u1 plus m2 u2 m1 v1 plus m2 v2, and the coefficient of restitution equation, that is v2 minus v1 divided by u1 minus u2. Rearranging, u1e minus u2e gives v2 minus v1. We get v2 as u1e minus u2e plus v1. Put this equation into here. We will get the equation for v1 and v2 for inelastic collision. For inelastic collision, we get v1 as m1 minus 2 em2. Sorry, this is not 2. This is em2 divided by m1 plus m2 into u1 plus m2 u2 into 1 plus e divided by m1 plus m2. See the magic. You put e value equal to 1 for this, and we will get the equation for elastic collision. So for v2 equation, we just have to reverse it. m2 minus em1 divided by m1 plus m2 into u2 plus m1 u1 into 1 plus e divided by m1 plus m2. So tada, we get the final velocities for v1 and v2 for elastic collision as well as for inelastic collision. Elastic collision as well as for inelastic collision. Now there are a few cases, a few special cases, and also some shortcuts for entrance obviously, that we will see in our next part. Thank you everyone for listening to my classes, and have a good day.